Hello viewers, this is Dr. Rana and today I am going to solve one heat transfer problem using COMSOL. I randomly select any problem and try to solve it with the COMSOL, and this will help you to solve any type of dimensional and non-dimensional analysis with the COMSOL. I'll quickly go to the Science Direct. I can write any problem on cavity or this finite element or non-dimensional heating. I preferably focus on the heated type of problem like heat transfer problem. So if I go and search, you can see that there is number of problems are published on this domain using finite element, cavity, or you can say that enclosure, different types of shapes on enclosure. You are already aware of making such type of two-dimensional domains. It's very easy within the console. I randomly select any problem. So this is problem published in 14, also 2005. I'll go for this problem and I can just download it. So yes, this problem is model is now downloaded with me. This 2005 problem, and problem is actually on, you can say that, on a cavity. Cavity is a square cavity. So you can see that in this square cavity it can be any practical type of problem, and you can construct any shape with this. So it's very easy in the console to solve any published paper which is wall is adiabatic, this is the cold wall, this is heated wall, and both are the heated with first is the constant temperature I think, and second is your variable temperature and as a function of sign. So you can see that this type of problem I am going to solve it, and you can see this is the model and this is a buoyancy driven force is there. So I'll taking the buoyancy forces in the COMSOL and I will show you. And the next there is the boundary conditions. After applying this type of similarity, you can say non-dimensional variable, dimensionless variable, you can say that it will convert to this type of model. So finally we are going to solve the dimensionless, so called non-dimensional form of model with the COMSOL. So I'll quickly start with the COMSOL. You can see that this model is little bit, I think the Prandtl number is generally in the temperature equation, but due to the modeling the non-dimensional number taken here, the change of variable are using, so Prandtl number exists here. So we can see that you can carefully handle this type of non-dimensional numbers on the COMSOL. So what you wish to know first? The value of the Prandtl number, value of the Rayleigh number, the dimension is constants, and you just going to, you can see that here the viscosity is not there. So you choose the dimensional model, put the values in such a way that they are converted to the non-dimensional model. So I'll start with the COMSOL. So model wizard, two-dimensional I can take. So I can start with any square rectangle, any square type of geometry. So laminar flow I wish to include it, and heat transfer of fluids, because two types of equation, first is momentum or continuity equation, and second I want the heat transfer equation. So I want both for this present analysis. So first laminar equation contain these three type of equations, and this equation is contained in heat transfer fluid model. So I'll go with this. So at the study, so what time? It's actually stationary study. You can see that here the time is not mentioned, so it's a stationary study. So I'll go stationary analysis and done. So COMSOL is little bit heavy software. I already mentioned you that if you are working with the workstation, then it is very beneficial for you. But if you are using your laptop personal with a low configuration, it may take a time, but still you can run the COMSOL on any platform. So this is first important thing. There's geometry. If you wish to construct a geometry first, dimensional variable doesn't matter, you can choose anything, and if you wish to construct, directly go to this, and rectangle you can choose, no problem. Square is okay, but you can use the rectangle and use the same dimension 1 meter, so it's okay. And you can use for the center, you can make the center as 0 0, and this So this is your, and so zoom up. So this is your domain, and XY domain is there. So this is okay with this, and I go for the global declarations. So you wish to right click on this and add the parameters. So when you click on parameter, you can write all the parameter which you're going to use. So I'll use TC with the value at 0, which is, you can say that, I can say the low temperature. So next I'll wish to TH, which is, I can take 1, because firstly I am taking the fixed value problem, so high temperature. Then you can use the Prandtl number. So in this model you can see that Prandtl is 0.2, and it's also a variable, so you can change later on. So now you can use it for the description. You can write it as it is, otherwise you can even upload all the values. P naught. So what I'm going to take, P naught is basically the pressure here. This is the value of pressure. In this model, the authors have used the penalty method, penalty parameter use it, and going to they are already eliminated using this, but I am going to choose any fixed value for the parameter. So my focus is here the finding the isotherms, because I am not eliminating this model. So I am using the heat transfer of the fluid. So I am mainly focus on this type of heat transfer contours. So if they are same, then we can see that we can solve this type of contours, this isotherms I wish to. So I am not verifying this, because I am taking the pressure term and I am plotting the velocity plots. So this is I am going to verify. So value of this is already been mentioned. Rayleigh number is used from this 10 to the power 3 to 10 to the power 6, and Prandtl number is for range this. I can fix it. I can vary the Rayleigh number as a parameter sweep I have used to use. So I'll go for the value. I can use it 0. This is, you can say, the reference pressure. So this is an interesting thing. You can also use the exact pressure here or the default. Rayleigh number I wish to sweep, so I can, at this time I can use it as a fixed. So next is mu. Mu basically your Prandtl number. Reason being, in this model you can see that where mu is replaced by PR. Here mostly in the dimensional model, generally you can see that here value is mu is given, but now I wish to replace mu with the PR. So I will wish to replace PR. So value I have PR is 0. This is called the body force, and which I will replace later on here by Fy. So we are going to use Fy later on. So this is all about the global declaration of the parameter.